All right, this next question has us working in the stock market where we have two different stocks, A and B, that all have expected yields and variances of those yields here to the right. We have three investment strategies. We can buy all of A, we can buy only B, or we can buy equal amounts of A and B. Now this first question asks us, how much of each stock A and B will we buy if we opt to buy equal amounts, or at least spend equal amounts of money in buying A and B? So with that in mind, we know stock A costs $20 a share and stock B costs $10 a share, and we have $200 to spend. Well, if we take $100 and put it into stock A and take $100 and put it into stock B, we know that $100 divided by this $20 per share will give us five amounts of stock A and 10 amounts of stock B. So the strategy for 3, we'll get the yield will be 5 shares of A plus 10 shares of B, because if we take $100 and buy $20 a share for A, that's 5 shares, and if we take $100 and spend it on $10 a share for B, that gives us 10 shares of B. Keep in mind that we have two other strategies, and that's going to play into these next couple of questions. We have strategy 1, which is buy only A, which means if we have $200 to spend and there's $20 a share for A, then strategy A has its corresponding yield function as being just 10A. We can straight out buy 10 shares of A and we can max out on A. In a similar fashion, our yield for strategy 2 will be to buy 20 shares of B because we have $10 a share and we have $200 to spend, so that's 20 shares of B. So that tells us all the different investment strategies and the different yields that we get based on the amount of shares that we buy. All right, the next question has us computing the expected value of each of these strategies. So let's start by taking the expected value of both sides for the first strategy. If I compute E of Y here, I get E of 10A. Per expected value rules, we know a 10 can come out of that expected value, giving us 10 times expected value of A. And since we know the expected value of A is 2, we have 10 times 2 is 20. Let's go forth and compute the expected value for strategy 2. The expected yield of both sides, 20B. Again, the 20 can come out in front like this. We know the expected yield for B is 0.9. 20 times 0.9 is 18. And then let's go to the mixed strategy where we take 5 shares of A and 10 shares of B. We're going to need a little bit more room, so I'm going to actually start here. We're going to say expected value of the yield will equal expected value of 5A plus 10B. One of the rules of the expected value is that the expected value of the sum is the sum of the expected value. So I'm going to split this up into expected value of 5A plus the expected value of 10B. Per expected value rules, this 5 and this 10 can come out as a coefficient in front of those expected values, so we end up with 5 expected value of A plus 10 expected value of B. I'm going to run out of room here pretty soon. We know the expected value of A is 2, expected value of B is 0.9, so we have 5 times 2 is 10, 10 times 0.9 is 9, 10 plus 9 gives me 19. So it's interesting to see that these different investment strategies give different expected values. On average, we can expect a return of $20, or let's say dollars. Dollars is fine. Assuming we're talking about US dollars here, or in the New York Stock Exchange. $20 is the return from strategy 1, $18 is the return on average from strategy 2, and $19 is the average return from strategy 3. Now you might think, well, clearly we should go with strategy 1 because it gives us the greatest return. Not so fast. Of course, with any investment strategy, we have to consider the risks that are associated with investing. This might be a high reward, but it also might come with a certain amount of risk, and that's what we're going to get into for a later part of the question. Okay, the next part of the question actually has us compute the covariance between the stocks A and B. So we're actually going to use this correlation formula here. I'm going to snag this guy and bring him down to the line below. I'm going to go ahead and write down the correlation formula. Now, we know the correlation is, I should actually draw an arrow here. We know, we're given that the correlation is 0.12. So we're going to put 0.12 here. The covariance we don't know, that's what we're looking for. The variance of A and B are given, 9 and 1. So we have square root of 9 times 1. It's going to give us a covariance of 0.36. Taking the square root of 9, that square root of 9 is 3. 3 times 0.12 is 0.36, so that gives our covariance between A and B. Let's write that up here because we actually are going to use that. Covariance is 0.36. We're going to need that a bit later. Okay, now we're moving on to variance calculations. So I'm going to erase this line. We're going to keep the yield as 10A and yield as 20B and yield as 5A plus 10B, but we're going to erase the expected value calculations because we don't need those anymore. Variance calculations are always a bit trickier, so I'm going to take the variance of both sides. Variance of y equals variance of 10a. When we take a constant out through a variance, we have to square that constant, so we end up with 100 variance of a. And since we're told the variance of a is 9, this gives us 100 times 9, or 900. This is what we mean earlier when I said something about this strategy might be being a more risky strategy. This is a really high variance for the variances we're going to see in a minute. We're going to compare this with the variance of strategy 2. We take the variance of both sides. Of course, when we take this 20, we have to take it out and square it, giving us 400 times the variance of b. Now, while that is a bigger constant than the coefficient we had before, the variance of b is actually quite a bit smaller. The variance of b is only 1, so 400 times 1 gives us 400. So this is a smaller variance than strategy A. And now we're going to come over to the variance for strategy 3. This is a bit longer. So we have to remember our variance formula for combined variables like A and B. So let's just be very careful here. Variance of y equals variance of 5a plus 10b. This combined variance, when I can split the variance, but I have to remember to account for a covariance term. So we have 5a plus variance of 10b plus 2 times the covariance of 5a comma 10b. All right, this is a doozy of a calculation. We're going to pull the 5 and the 10 out through the variance and square them. We can also do the same for the coefficients here, but we don't need to square them. So watch this next line very carefully. We're going to end up with 25 variance of a plus 100 variance of b plus this 5 comes out, this 10 comes out, 2 times 5 times 10 is 100. Don't need that parentheses. And now, knowing what we know about variance of A, variance of B, and the covariance of AB, we can get an exact number for this. 25 times variance of A is 9, 100 times variance of B is 1, and 100 times this covariance of 0.36 altogether gives us a variance of 361. So it's important to remember this covariance term because otherwise you get everything wrong. We can say this covariance term is 0 if we know that A and B are independent, but we were told that A and B had some sort of correlation earlier, and from that we could figure out the covariance is, allowing us to figure out the combined variance of A and B. Okay, now we're asked some simple question about what it means to lose money on a particular strategy. You might think that maybe one of these has to be negative, like A has to be negative, or B has to be negative, or they both have to be negative. But in order for an investment to return you, in order for an investment to return a loss, it only means that that investment returns a negative number. So it's an amount that's less than 0. I know that's what a negative number means, but that's going to be important for part 6, which is how to figure out the probability that any one of these strategies loses us money. Okay, so first things first is let's identify the idea that for an investment to lose us money, the investment returns a negative amount. So that's pretty simple. This is true regardless of what strategy you use. I think part 5 or what this next part says, when does strategy 3 lose us money? Well, this is true for any strategy. It's whenever the investment strategy has a value that is negative. So that's important to keep in mind. We're going to use that information to help figure out whether what the probabilities are that correspond to these different strategies losing us money. All right, for the last part, we want to figure out which of these strategies is more likely to lose us money and which strategy is less likely to lose us money. You'll notice I've put the expected value of each strategy here and the variance from each strategy as we calculated them back in parts 2 and 4. Using these numbers, we can figure out the z-score that corresponds to losing money based on this formula and figure out the probability that we lose money based on that. And this might make sense in the real world. We might want to be, maybe we're running a hedge fund or maybe we're trying to invest our money in such a way that we want to minimize the chances we lose money as much as possible. So what we're going to do is we're going to say to ourselves, remember answering, as we said in part 5, what does it mean to lose money on an investment? It means the result or the return on your investment was negative. So the breaking point between positive and negative numbers, we call that 0. We're going to find the z-score that corresponds to 0 for each strategy. So for strategy 1, our z-score would be 0 minus 20 over the square root of 900. Remember, this has to be a standard deviation, or 30. That corresponds to a z-score of negative 0.66. Let's also compute the z-score that corresponds to losing money for strategy 2 and strategies 3. We have 0 minus 18 over the square root of 400 is 20, and this gives us a z-score of negative 0.9. And this is 1, this is 2, and this is 3. And let's find the z-score that corresponds to losing us money in strategy 3. The mean was 19. The standard deviation was 361. The square root of 361 is 19. So this comes out to be -1. That's a -0.9. And so now we need to figure out, let's make some room for it over here. Now that we have z-scores, we can take these z-scores and plot them on this curve, this z-curve, and find the probability that we end up left of that, because we were trying to find the probability we lose money. So that's being up on the negative side of this thing. So finding the probability that we're less than this. You could write the probability that z is less than -0.66, and that comes out to be about 0.25. And again, you can do that using a z-table, or you can use a graphing calculator to help you figure that out. We can also do the same thing for this z-score and this z-score. This is strategy 1. The probability we lose money is 0.25. The probability that you lose money with strategy 2 is the probability that z is less than -0.9. And either using a graphing calculator or a z-table, we find this probability is 0.18. And the probability that z is less than -1, our z-score from strategy 3, is 0.15. So notice that the likelihood we lose money in strategy 1 is 0.25. The likelihood we lose money in strategy 2 is 0.18 or 18%, and we are least likely to lose money in strategy 3, where we have a 15% chance of losing money. So it seems as though strategy 3 might be the best if we're trying to avoid losing money. Going forward, though, it's important to keep in mind that just because the probability we lose money is the smallest for strategy 3 doesn't mean it gives us the best chance to gain money. So we might turn this problem on its head and figure out what's the likelihood we earn a lot of money with a certain investment strategy. And we might find that strategy 1 or strategy 2 gives us a better chance of earning money based on their or at least based on strategy 1's high expected value. But that's what we mean when we say high risk, high reward, is that, well, it might be true that the strategy 1 might give us a best chance of earning money or earning more money than other two strategies. It also comes with a higher risk of losing money. So that's where we get the phrase high risk, high reward.